Bazel at the edge, building for the world's toughest environments. And the first disclaimer is that I'm not a real developer. I'm actually an AI. No, I'm just joking. I'm a real person, I promise. But I'm from the United Nations Population Fund. And then you might be wondering, what is the UN doing at BazelCon? Are you a software company? But I mean, someone also said that in the future, almost every company will be a software company. But yeah, you're right. The UN is not a software company. We are actually a humanitarian organization. And my organization works with different countries around the world to promote better reproductive health. And we help the countries to organize their censuses for their population. And then my job here is to architect and deploy high-stakes data systems in some of the world's toughest environments. And today, let me see. Today I want to kind of tell us a story. And it's a story about what happens when your build target is not in a server room, but it's somewhere in a location like this. This is my cloud environment for me. So the device here, the endpoint here, is at the literal edge of the world. And it's a story about why the work that you do, or the work that most of us do, is more important than we can even relate. Yeah, so think about a field clinic, a clinic somewhere in some remote place in maybe Africa. And you have people trying to register, or have refugees going, trying to get onto the system. There is a, oh, sorry. Yeah, so think about a field clinic, and people are trying to get resources. They're trying to get medical health care. They're trying to get registered in some system to get aid. And we have to run this kind of complex data pipelines and AI systems that people literally depend on for their lives. And that's where we have some constraints, some interesting constraints, which I call here, it's the humanitarian edge. The humanitarian edge here is one, it's a little different from what we have maybe in the West. It's, for one, there's the devices here are kind of low-powered, rugged laptops. So forget about any kind of fancy 96 core, or it's probably just some dust-laden laptops. Second, there, the location. It's a field clinic. It's a mobile unit. That's here. It's me in a mobile registration unit working on some systems. Connectivity is also a big one because there is none. It's kind of it has to be offline first, 100% offline. The app has to work without the internet. Sometimes when we get back to some central hub, we can synchronize with the server. Finally, maybe most importantly, is the data. We work a lot with kind of critical, sensitive data, people's personally identifiable data, which needs to be encrypted. We have machine learning models we use for forecasting, and I mean, here in the picture, we're dealing with biometric data as well. So just to show the criticality of the data that we work with. So this kind of brings us to the kind of big stakes we have. And then in terms of our deployment, we only have one shot to get it right. So in this kind of situation, we don't have git pull, there's no rollout undo. We have to work off the local server. So if any failed deployments can literally bring down the whole system. It's literally I was joking with someone. I said our deployment pipeline is literally a guy with a USB stick on a motorbike, and I say, look, take this and deploy it in the field to make sure it works. That's literally our kind of CI/CD joke that we do there. But these are kind of life-saving applications that we need to work on, and we need to get it right the first time. So with this, there is also the technical challenge, which I kind of phrase into two parts. One, the pipeline, which most of us will be familiar with. So we're dealing with kind of complex multi-language applications. We might have, on the one side, some Python application connecting to a TensorFlow for our machine learning models. We might have some C++ libraries for high-speed data validation. We also would have like Go binary for cryptographic services. It's kind of just a mix of everything. And then on the other side, there's the failure mode, which is kind of the kind of slippery slope that we work on, because any kind of subtle dependency could mean that the whole system doesn't work. For instance, you have a Python model that was trained on one version, but is deployed in a different environment, or a C++ library that was built on the wrong OpenSSL version. So those kind of complications are what we have to deal with. So it's beyond the saying where we say, oh, it works on my machine, why is it not working on yours? It has to work all the time. It has to work everywhere, essentially. So I think the next question is then how do you trust a build? How do you make sure that what you have in tests is the same as what you have deployed? So to bring that thing of, oh, it was working on my system, why is it not working on yours? That can actually get you fired, because it's not working, it's not working. So we need more than it seems to work. We kind of need some mathematical certainty that we can have a guarantee that it works all the time and it works the first time. So in this time, I will say that the build is the build tool that we have to use is not just a it's not a nice to have. It's kind of a necessity at this point. And this brings me to why I'm kind of here, is that with Bazel, some of these things are taken care of. So at the moment, Bazel now goes from a nice to have at maybe some funk company to actually being a mission critical enabler for the work that we do in some of these humanitarian settings. First of all, hermeticity. We've talked a lot about this in some of the past, but this means that our build is sandboxed. There's no network access, no undeclared dependencies. For us, it's not just about the speed. It's actually that if the build passes, we know that every single file, every single library, every single config that it needs is available. The next one there says, I need to take a breath for this one, reproducibility. Got it. And this is just like the build is a pure function, that the same code always reproduces the same output. That's kind of our guarantee, that the build that we test during the CI is the same and are very identical to the build that I give to my friend with a USB stick on a motorbike. And finally is accountability. So because of this, we can prove that exactly what code and what model that we run is also running everywhere. So we kind of know what dependencies are running on the device, even if the device is in the middle of nowhere. For some of these high-stake applications, this is a non-negotiable, particularly for AI systems. So we have kind of a pattern that we use, and it's basically simple. I call it the deployable archive, where we just use a package tar rule to create a single self-contained deployable archive. And the archive will contain kind of everything that we need, the combined C++ code binaries, the entire Python runtime. Sorry, I'm just noticing this. I didn't even know this was here. I was looking at somewhere all the while. And critically, all the static data files that we need, the trained ML models, and the root certificates, which are kind of important. And the result is that we have a target device that needs nothing but the base OS and just the tar command to unarchive it. And then it runs smoothly. So with Bazel, we have that confidence to do that. So building is half the battle. We also have to test it. And then we use a Bazel test kind of as a baseline for our unit and integration tests for all the code, all the languages, all at once. 1 minute. No way. Okay. Secondly, we use hermetic integration tests to run it. And finally, we have our one-step validation in our CI. I'll just run through that then. The payoff is that we have reliability as not just a feature, but a kind of a prerequisite for trust. In our work, trust is the only currency we have because we work with people who have to trust us. And just another disclaimer, this is not a Chinese proverb. I thought it was just nice to have it as a Chinese proverb. I just thought about that. Next, so this is what we call Bazel for social impact. This means that the tools that you build, they contribute to to make our lives better, make our lives faster. It kind of makes everything that we do, it brings it all home, and we kind of see it in real life, see how it affects people's life really. So just some key takeaways for engineers, developers. If you work in, or if you happen to work in any resource constrained systems, try Bazel. When you only get one shot to deploy, that hermeticity is very, very important. For the Bazel community, let's continue to defend these principles. The focus on reproducibility is what enables us to have that trust and that accountability that I was talking about. And of course, let's continue to share the story. The work that we do has also profound social impact. Many of us are core devs, so we don't see the work that we do on the other side, but it has real social impact. I also got a couple of GitHub repositories I'm going to try out, so continue to share them. Some people on the other side of the world are looking at what you do, and we are also emulating and copying. Yeah, that's thank you for attending BazelCon 2025.